Question 5. As I said, this is really important that you know how to do two-dimensional vector problems for Physics 30, because the first unit on momentum and impulse is exactly that. It's a lot of two-dimensional collisions, and you have to be able to resolve things, vectors into components, and then add them. So let's make sure we go over this one carefully. A particular pass pattern requires a football receiver to run 15 meters north and then 10 meters 45 degrees west of north. Refer to the information in the pass pattern to answer this question. The magnitude of the resultant displacement is, all right, so let's do a little sketch first. So first we're going 15 meters north. So 15 meters north. Always makes it a little simpler if one of them is like due north or due east or due west or due south. And then 10 meters 45 degrees west of north. So 45 degrees west of north would be like that, and that's 10 meters. And so your resultant vector is this one right here. Right, and we can see, it's 45 degrees. We can see that the resultant is going to be longer than both the single vectors. And we can see approximately what angle it's going to be at. So two ways you can solve this. The easiest way to do it is to just find out what this angle is here and use the cosine law. But that is not required. It's not required for you to use the cosine law. So we're going to do it the long way first, and then I'll quickly show you how to do the cosine law in case you want to do it that way. And the long way works for every question, whereas the cosine law or sine law may only work for specific questions. So that's why we learn separate into components. So we're going to take each vector and separate it into components. And the red vector is easy. Let's just do the red vector right here. The red vector has an x component of 0 and a y component of 15 meters. Right, so that's why it makes this question a little easier. Then we're going to take the other one, this one here. That's your 45 degrees. That's 10. It has a westerly component and a northerly component, x and y. And we're just going to use trigonometry to calculate what those x and y values are. And again, this question is made easier by the fact that that's 45 degrees. Because in a 45-degree right-angle triangle, x and y, the two legs of the triangle, are always the same. So let's say we're calculating x. We would use sine of 45 equals x over 10. And therefore, x equals 7.07. And then we use cosine to find y, but since it's 45 degrees, we know that it must also be 7.07. All right, so that's step 1, separate everything into components. Step 2, add those components. So step 1, 2. All right, I've added those. The total x is 7.07 west, and the total y is 22.07 north. And just a reminder, that's only because you have to make sure that you use the same signs, or you have to make sure that you take note of the signs. For example, if I give you an example where one vector was like, well, let's do this. If one vector was north and the other vector was like this, then for this problem here, you would end up subtracting the y components because this has a negative y component and this vector has a positive y component. So just make sure you're aware of the sides. Now that we've done that, we can go to step 3, and step 3 is to make a new triangle with the vectors. Oh, sorry, with the new components that we have, 7.07 west. And then just solve the triangle. Find the resultant angle. And if you look ahead, you can see the question 6 wants the resultant length and then the resultant angle. So we can answer questions 5 and 6 right here. We can use Pythagorean theorem to find the displacement. And then we can use inverse tangent to find the direction. All right, and the resultant turns out to be 23 meters D. And then for the angle, you're just going to use the inverse tangent of the opposite, which is 22.07, divided by the adjacent. And when you plug that into your calculator, you're going to end up getting 72 degrees. Okay, now be careful here. Be careful, because don't just jump to the answer B, because B is not the right answer. 72 degrees is, remember, this is 0 degrees, and if you're using the Cartesian system, then you go in a counterclockwise direction. So this is 72 degrees right here. And clearly, that's not what our resultant is here. This is our resultant right here. And so let's go back to our diagram right here. If that angle there is 72 degrees, what is it? So it's clearly going to be C or D. Is it 18 degrees west of north, or is it 18 degrees north of west? 18 degrees goes in there because that's to equal up to 90. So the answer is C. It's 18 degrees west of north. Right? Or, and there are 3 other ways that you could express that answer. It could be north 18 degree west, or west 72 degrees north, or 72 degrees north of west. All right, and if you're using the navigator system, then the answer would have to be, if this is 18 degrees in here plus the 90, so the answer would actually have to be 108 degrees. So there was no north, south, east, or west. It would have to be 108 degrees. But just a reminder, on your final exam, we're always going to use north, south, east, or west. Okay, onward. Number 7 is projectile motion. A marble is projected from a cliff at a horizontal speed. So here's a cliff. Here's your marble. It has a horizontal velocity of 2.5 meters per second. So this one, it doesn't have, and it has 0 vertical velocity initially, and then it's obviously going to go down. It's going to accelerate vertically, and it's going to hit the ground. And the question wants to find out this, the displacement, the vertical displacement, or the height of the cliff. Okay, so a reminder for projectile motion problems, we usually separate things into the horizontal components and the vertical components. We may not need to do all that work, but let's just do it to go through all the steps. So let's write down what we have from a horizontal perspective. We have the velocity. Do we have the time? No. Do we have the displacement? No. This is the horizontal displacement right there, or the range, as we commonly call it. So that's what we have from the horizontal perspective. From the vertical, what do we have? Well, we have the initial velocity, because it initially doesn't have any vertical velocity, so that's 0. We have acceleration due to gravity. Do we have the time? No. Do we have the final velocity? No. Do we have the distance? No. Wait a minute, we're missing something here. I gotta go back and read the question. Oh, we do have the time. Look at that. So we have the time actually for both of them. The time is 1.2 seconds. 1.2 seconds. So for the horizontal components, we could calculate the displacements or the range, but that's not what the question is asking. It's asking for the vertical displacement or the height of the cliff. And I'm just going to, so we don't need the final velocity. Let's make this a little bit here. So the time is 1.2 seconds, and we want to know the displacement. So we can do this in one step. We just need the one equation. It's this one here. Plug the numbers in, the VI being 0, we'll just eliminate that first part. And that will spit out an answer of 7.06. And it's negative because it's going down, so which is irrelevant because it just wants the height of the cliff. So the answer is 7.06. All right, that should help us out with the next question, because the next question is projectile motion at an angle. And we've got a baseball batter hits a ball from ground level with a speed of 25 meters per second at an angle of 65 degrees. 65 degrees, fairly steep, and this is 25. And once again, we're going to have to calculate, we're going to have to separate this into components using sine and cosine. So let's do that right off the bat, and then we'll organize all our information. So x is going to be cosine. Cosine of 65 degrees equals x over 25. X equals, what does it equal? 10.57. Instead of here, y is the sine of 65 degrees, and y turns out to be 22.66. All right, now let's organize our information the way we just did it. So let's see what we have horizontally, and let's see what we have vertically. Horizontally, do we have the distance? No. Do we have the time? In this one, we definitely don't have the time. Do we have the velocity? Yes, we do. This is the horizontal velocity. And a reminder that the horizontal velocity is always constant. It's uniform motion, constant velocity. So it's always 10.57 meters per second. What do we have from the vertical? Do we have the initial velocity? Yes, we do. Do we have the time? No. Vertically, in projectile motion, we always have acceleration due to gravity. The displacement we don't have, but that's what we want. And do we have the final velocity? Okay, well, in this one, yes, we do. Because if we're trying to find the, wait a minute, am I reading the right question? This is the, we're trying to find the maximum height. Yes, so we're trying to find the maximum height. So we do have the final velocity because at its maximum height, here's the flag of the baseball. At its maximum height, the velocity is 0. So let's find a formula. That's going to be the final velocity. Let's find a formula that has VF, D, A, and VI in it. And that's going to be your and that's it. So this again is a one step well, it's multiple steps, but you only need to use one formula. And that's going to give you, plug your numbers in, and you're going to get an answer of 26.2 meters. Okay, now same question, but this time we want to find the maximum range. So to find the maximum range, we're going to use the horizontal component. And we look what we've got horizontally. What do we have? We have the velocity, and remember it's constant velocity. We don't have the distance and we don't have the time. We're trying to calculate the time. So therefore, sorry, the distance. So therefore, we need to calculate the time first. And since we don't have enough information in the horizontal component, but we do have enough information in the vertical component. So as long as you've got 3 pieces of information, you can find the 4th. Now, I am going to do this a little differently. So from the vertical component, and I'm not going to use an answer from number 8. I'm only going to use the information that was given to me in the stem of the question. So the initial velocity was 22.66. The acceleration due to gravity, time is what we're trying to calculate. We have to calculate the time because the time applies to both the horizontal and the vertical component. Now for this one, I am going to use, I'm not going to use a vertical velocity, final velocity of 0, although you can, and then just multiply the answer by 2. I'm going to use a final velocity of negative 22.66. Because when the ball goes up, it's positive. When it comes down, right before it hits the ground, is negative 22.66. And then I can just use this formula here. Which I'll manipulate for t, and then plug those numbers in. Negative 22.66 minus 22.66 divided by negative 9.81, and you're going to get 4.62 seconds. And then you can go to your horizontal component to calculate the range or the horizontal displacement. Don't forget to use the correct velocity. So if you go back to your horizontal, your velocity is 10.57. It's constant velocity, so we can use this formula here, d equals vt. Multiply this together, you get 48.8. Okay, that ends this video. Next one, we'll start with number 10.